Hello everyone, this is Samyak Agrawal of the class 2K16, and in this video I'm going to explain the solution to the problem 1 of a science project 1. So the question goes like, we have to find the probability that the cat and the rat, which are located on a square grid of length L, meet after n steps, given that both of them follow a 2D random walk. So what we can do is, to simplify the problem, we can make the cat stay here and analyze the movement of rat with respect to the cat. So the total number of ways in which the rat can now move is 4 ways for the rat to move and 4 with respect to the cat. So it can go like this: first up and then right, down and then left, and there will be a total of 16 such possible ways. In order to further simplify the problem, what we do is we consider the motion of the rat independently on the two axes, that's the x and the y axis, and then solve each of them like a 1D random walk with a little change in probability distribution function. So it goes like, so the total number of ways in which the rat can move in one axis and with respect to the cat is this. So if suppose the rat moves in the negative x direction, we take it as -1. If the cat moves in the same direction, so the relative path will be -1 or minus of -1, that is 0 with respect to the cat. And similarly this, so the probability of the rat moving in each direction goes like, it goes -2 steps to the left, the probability is 1/4. If it goes +2 steps to the right, the probability is 1/4, otherwise it's 2/4. If it doesn't go anywhere, it either moves 1 and then -1, or 1 and then -1 and then 1, so that is 1/2. So the motion of the particle is now defined. Since in the question reflecting boundary is specified, we need to check for the edge cases as well. So the edge case goes like, if it's on the right hand side of the grid, so it's on the right hand edge of the grid, so it should go back to the left. But what we can consider is, we can consider a virtual world to the right, so that if it wants to go to the right, it still keeps on moving to the right. So we so now we don't really have any boundary conditions or any constraints to the movement of the rat in that on that axis. So but there is a problem, that because we only consider the motion of the rat, but what about the cat? So each time we flip the boundary, the image of the cat will be made in the virtual world as well, in order to solve it. So assuming that the rat to be initially at origin and the cat to be on L comma L, this is L and this is L. So the cat will now be found at 2k plus L. So that is here, if we decide to move towards the right after reaching this right edge. So now let's calculate the probability of them meeting. So let the probability of finding the mouse at some x in its motion on some x, during its motion in one of these dimensions, and let that be p of x. So as we know that the motion of the rat is independent for both the directions, what we can do is we can calculate it for x and it will be same for y, and the total probability will be the multiplication of both of them. So our answer would look something like this, because we also have to consider all the planes that we have taken, the virtual planes. So our final answer will be this, because it will go from L, the number of planes can be infinite on either side of the axis, so it can go towards the right and the left, and also down and up. So so let's find out the probability in x direction on the x-axis. So let it take let x steps be the number of steps that it has to take in order to reach the cat directly. So suppose if the cat is at L and our rat is moving towards towards the right on the x direction, on the x axis. So as it is taking 2 steps each time, so that means that 2x equals to L, so x equals to L by 2. So in similar way, the remaining number of steps is n minus x by 2. And we don't really care about how it moves in those steps, because we only need the rat to be stationary and not produce any further displacement from after reaching L. So let's consider this. So now let's say that it moves y number of steps in one of the directions. Let's say makes y number of steps towards the right. Now we also want it to take y number of steps in the left direction, so that so the net displacement remains 0. So total number of steps that it can move towards the right is x by 2 plus y, and to the similarly there will be y number of steps towards the left, and the remaining n minus x by 2 minus 2y can be like, it can be there in the y direction. We don't really have to bother it right now. So the total probability goes like the total number of the probability in which it can go to the right, that is 1 by 4 time to the power x by 2 plus y, 1 by 4 to the power y for left, and for up and down it's this. And this is the total distribution that we can have. So we can solve this problem, and the summation of that problem will give us px in terms of x and n, and similarly we will have y, and our final answer will be this. So for the next question, most of the problem remains the same, the most of the solution remains the same, but now we have both cat and the rat at the center of our grid and not on the diagonally opposite end. So the only difference it will make is if we are considering the virtual world, instead of the cat being projected at 2k plus 1 comma 2p plus 1 of L, it will be something like a of L and b of L, because it will still remain on the center of that grid. So our answer will be the same, but instead of 2k plus 1 times L, 2p plus 1 times L, it will be a of L times b of L. Thank you.